Okay. Hello, everyone. Good afternoon. My name is Xiaohui. I'm coming from the Intel Open Source Technology Center. And today, my topic is HAXM accelerates Tizen SDK Emulator on Windows and Mac OS. Here is the agenda. First, we will introduce Tizen SDK Emulator, and then, what is HAXM? And the third section should be HAXM accelerates Tizen SDK Emulator. And then we will do a short summary. And the last will be the question and answer time. The first one is the Tizen SDK Emulator. Okay, we all know that the Tizen SDK includes a virtual device emulator. It supports full stacks of Tizen platform. Application developers can utilize the Tizen emulator to test their applications before they want to run the application on the real device. It's useful, at least. Sometimes that the application developer cannot be guaranteed to get the latest hardware in time. The SDK emulator implementation is based on the QEMU open source project. It includes the CPU emulation and the various device emulation. Currently, the Tizen SDK emulator supports x86 architecture, and it is tightly integrated in the Tizen SDK. There is an application named Emulator Manager. Users always utilize the Emulator Manager to configure a virtual device and launch it. The Tizen SDK emulator, like the Tizen SDK, support Linux, Windows, and Mac OS. Then here is the picture. It shows how the emulator VM looks like on a Windows host. And the background is a Tizen SDK IDE window. And here is a picture shows how the emulator VM looks like on a Mac host. We can see that they are almost the same. The Tizen SDK emulator provides such features that it supports full system emulation. As we have explained before, it is based on the QEMU project. The second, the emulator supports the event simulating. There is a component in the Tizen SDK IDE named the event injector. This component can issue events to the emulator VM. For example, it can issue a phone call or a short message to the emulator VM, and the emulator VM will receive it and respond to it. All of this will help the application developers to test their applications. At last, the Tizen SDK emulator utilizes the hardware, CPU, and the GPU feature to accelerate the emulator VM operations. To utilize the hardware CPU means that we can call it a hardware virtualization. And for the utilized hardware GPU means that the emulator supports a set of GL implementations, and both of them will improve the performance of the emulator. And here, why HAXM is needed? The reasons are simple. The first one, that the CPU instructions emulation in QEMU side is slow. Although there are a lot of optimizations in QEMU, but it is a pure software emulation. The performance is not that good. Second, the hardware virtualization technology is mature and is already ready to use. The most famous ones are the Intel VT technology and the AMD virtualization. And the third reason, on Linux OS, the KVM is very popular, and the Tizen SDK emulator can easily utilize the KVM as their hardware virtualization solution. The performance is pretty good, but Windows and Mac OS still lack such feature. And currently, the Tizen SDK emulator can utilize hardware CPU in multiple platforms. On the Linux side, it should be KVM, and on Windows and Mac OS, both of them are HAXM. Here is a picture. It is the emulator manager window. And from here, we can see only one virtual device is configured. And in the red block, it is the hardware virtualization feature. If the host has installed the HAXM or the KVM driver, then this feature is enabled by default. That's why maybe many Tizen application developers never notice that there is a HAXM on the side. Okay, so any questions here? No? Then the next section. What is HAXM? So what is HAXM? Basically, HAXM is a VMM. VMM named Virtual Machine Monitor. And HAXM is a VMM tailored for QEMU-based emulator, such as Tizen emulator. HAXM is a hosted VMM. It likes KVM. This kind of VMM works as a host driver and usually works together with the QEMU because it wants QEMU to be responsible for most of the device emulation. And this kind of VMM use the host OS service to implement virtualization. And each emulator VM running on the host is controlled as a host process. HAXM already utilizes the latest VT feature, such as the EPT feature, extended paging table. EPT feature is a very important feature for the memory virtualization, and it will greatly improve the performance. Okay, the HAXM is an outstanding performance accelerator for the Tizen emulator. HAXM feature. Currently, HAXM has a well-defined interface between the QEMU side and the HAXM driver. Basically, this HAXM interface is a set of device I/O control operations. And currently, only the Intel VT technology is supported. HAXM also has good x86 architecture correctness. For example, the same binary built for the Tizen emulator can successfully boot an Android emulator as well, although the Android platform is very different from the Tizen platform. HAXM support both the Windows and the Mac platforms. We have made a good implementation that we had an OS wrapper layer and use this wrapper layer to wrap the host differences. And based on this, we had a maximum common code base. HAXM is a closed source license, and it's Intel property. The full name of HAXM is Intel Hardware Accelerated Execution Manager, and it is presented as a service in Windows. We can see this picture from the control panel. If HAXM driver is installed, then we see in the red block, there is the Intel Hardware Accelerated Execution Manager there. Also, we can check from the command line tools. We can query the HAXM service from the command line. The service name should be Intel HAXM, and see this picture, it's running. And on the Mac OS host, HAXM is presented as a kernel extension. We can use the kernel extension tools to search the HAXM driver. Current status for HAXM on the Tizen side, we support 5 Windows OS types, that is Windows 7 64 and 32-bit, Vista 64 and 32-bit, and the Windows XP 32-bit. And on the Mac OS, because the Tizen SDK currently only runs on the 64-bit Mac host, so we support Snow Leopard 64-bit, Lion 64-bit, and Mountain Lion. And currently, HAXM version for the Tizen SDK is 1.0.5. Okay. Here is the performance data. And please notice, all the data is collected on an Intel i7 CPU, 2 cores, 8 GB RAM, and it is on a 32-bit Windows 7 host. We only let one virtual device run on the host. So the results may vary depending on the different Intel machines and other combinations. Let's see some of the data. The left column is the benchmark items. We have at least 5 items there. Okay, I have remembered that when we tune the performance, only the boot time and the sound spider are cared by the emulator team, and the other 3 ones, for the GUI Mark III benchmarks, the performance data is only taken by our developer side. Here, the first one is the boot time. The boot time is to measure the time from booting an Tizen emulator VM till showing the home screen. We can see that without HAXM, it needs nearly about 3 minutes. And with HAXM, it needs 30 seconds. The next item is the Sound Spider. Sound Spider is the famous JavaScript benchmark. It measures the time to cover all the JavaScript test cases. And we can see without HAXM, the time will be more than 8,000. And with HAXM, it's about 440. The other 3 benchmark items for the GUI Mark III. It's to measure the HTML5 canvas performance. We can see it will test the bitmap drawing and the JavaScript computing and the vector drawing. Here, for the bitmap drawing, we can see with the HAXM, the number is 8 frames per second. This is not good, but it is 20 times than the without HAXM cases. And for the other 2, the data looks better because if the data is about 13 frames 1 second, means that the human eyes will feel the graphic is smooth. Anyway, we can see that the HAXM can improve performance with the emulator greatly. So, any questions here? Okay, then the next page. This is the 3rd section, how HAXM accelerates Tizen SDK Emulator. Here is the HAXM Big Pictures with the Tizen emulator. Okay, the dark blue one indicates the host-related items, and the light blue one indicates the HAXM-related items, and the purple one indicates the guest. The left corner there is the emulator manager. It is the application the user used to configure a virtual device and launch it. We also called a virtual device as a VM or as a guest. So when an emulator instance is launched, actually a QEMU process is running on the host. When the QEMU noticed that the HAXM is installed, then it will try to communicate with the HAXM driver through the well-defined HAXM interface here. And it's the HAXM driver's responsibility to finish the hardware virtualization tasks. Basically, it includes three parts. The first one should be the CPU virtualization. Okay, for the CPU virtualization, the basic idea is that to let the guest to run directly on the host as possible as it can. Intel VT technology introduces two modes for this. One is the VMX non-root mode, and one is the VMS root mode. The guest can only run in the VMS non-root mode, and only the VMM can run in the VM's root mode. It's the responsibility for the HAXM driver to make the host to enter the VMS non-root mode, and only in this mode the guest can run directly on the OS, on the host. And when the guest runs unprivileged instructions, the host will let it be. And when the guest runs privileged instructions, then the host will automatically into the VMS root mode. We call it a VM exit. And before, we have explained that it's the HAXM responsibility to make the host to enter into the VMS non-root mode. That is the VM entry here. Sorry. And when guest runs the privileged instructions, then the VM exit happens. In this case, the guest cannot run directly on OS again. And the HAXM driver will take the CPU control and decides if he can do some job on behalf of the guest. If yes, HAXM will help the guest to do and prepare the next VM entry. We can see another picture here. Here. HAXM driver, after a VM exit, HAXM driver will help the guest to do some job. If he knows that the guest will resume to run. And in other cases, the HAXM doesn't want to handle this case, then it will return to the QEMU side. Okay. Then here is the task for the HAXM driver to finish the CPU virtualization. And to be a VMM, HAXM driver is also responsible for the memory virtualization. Then, why memory virtualization is needed here? There are two reasons. The first, the guest believes that its physical memory region is start from 0. And second, the guest believes that its physical memory region is contiguous. Both of them are true for the native OS, but both of them cannot be guaranteed for a guest which is in a virtualization environment. The guest physical memory is littered here and there and sparsely sitting in the host memory region. So there is a mapping from the guest physical address to the host physical address. And it's the responsibility for the HAXM driver to deal with the P2M mapping. And it's the main task for the whole memory virtualization. Depending on whether the EPT feature is supported on the host, the implementation of the VMM driver is very different. But in general, the EPT case will have better performance than the non-EPT case. And for HAXM driver, currently we support both the EPT case and a non-EPT case. Okay. And to be a VM, HAXM driver should also be responsible for the I/O virtualization. The I/O virtualization basically includes the I/O memory access and interrupt virtualization. The I/O memory access basically includes the MMIO and port I/O, and both of them are privileged instructions. As we have said before, when guest runs privileged instructions, then a VM exit will happen. And in this case, HAXM driver will get the CPU control. In this case, he doesn't want to help the QEMU to do this. He doesn't want the guest to do this, so he will return the CPU control to the QEMU, and the QEMU will emulate the instructions for the guest. That's why we doesn't put I/O memory access in the block. We only put the interrupt virtualization here. So for the interrupt virtualization, it's the responsibility for QEMU to detect the virtual interrupt issued from a virtual device. And if there is one, then it will notify the HAXM driver, and the HAXM driver will store the information. And when next VM entry happens, the host will automatically inject the virtual interrupt into the guest OS. That's all for the HAXM jobs to finish the hardware virtualization. So, any questions here? Okay, then the next page. Okay, this page shows how HAXM works with the QEMU side. It simply describes the tasks HAXM has done and the tasks the QEMU has done. So the HAXM is responsible for the CPU virtualization in predicted mode and the memory virtualization and the interrupt virtualization. And for QEMU side, it is responsible for the real mode CPU virtualization and the MMIO and the port I/O emulation. Okay. Here is the picture to illustrate how the Tizen emulator VM executes when HAXM is enabled. As we have said, the QEMU is responsible for the real mode instruction emulations. So after that, if the HAXM is not enabled, then all the instructions for the guest will go through the left cycle. All the instructions will need the emulation from the QEMU side. The mouse doesn't work here. Yeah. Okay. Okay. So if the HAXM is not enabled, then all the instructions will go through in the left side, in the left circle here. Will through the QEMU, needs the QEMU emulation for it. And if HAXM is enabled, then the QEMU will let HAXM to work, and it will make the guest to run directly on the host. In this case, most of the instructions don't need the QEMU to do the emulation because all of the unprivileged instructions will be executed by the guest itself. And some of the privileged instructions will be handled by HAXM only. The privileged instructions that HAXM don't want to handle or some exception cases, then it will return the CPU control to the QEMU. Only these instructions will need the QEMU's emulation. Okay, any questions here? Then, next page. This one we have explained in previous pages. So, next page. It's the HAXM code structure. Basically, we have two parts for the HAXM. One is the HAXM driver module, and one is the HAXM interface in the QEMU side. So for the HAXM driver module, basically it splits into three parts. One is the core part for all the hardware virtualization tasks. For the CPU virtualization, memory virtualization, and the interrupt virtualization. And the other parts, both are the driver wrappers. One is for the Windows, and one is for the Mac OS. And in QEMU side, the HAXM interface is split into two parts. Then one is the OS-independent interface, and the other one is the host OS-specific driver I/O operations, like device I/O control in Windows side and I/O control in the Mac side. Here is the HAXM interface in the QEMU side. We list a bunch of functions here. And I think from the name, it's easy to be understood. What the HAX init is to open the HAXM device and do some initialization works. And to get the capability of the HAXM, to get the version of HAXM, and to create a virtual machine structure for the HAXM, to create a virtual CPU structure for the HAXM. And HAX vCPU exec and HAX vCPU run, just to make the HAXM to run, and the HAX vCPU interrupt to notify HAXM about a virtual interrupt, and then to destroy the virtual CPU structure and the virtual machine structure. Here is the list. Okay, here is the short summary. HAXM is a simple VMM working for the QEMU-based emulator, and HAXM works on Windows and Mac OS. HAXM accelerates Tizen SDK Emulator with great improvement. So, next one is the question and answer time. Any questions here? Thank you.
First, just to say, HAXM is great.
Thank you.
Developing in Windows with the emulator before HAXM was extremely painful. One challenge we have is discovering if HAXM is installed correctly and enabled, turned on or not. Have you considered a menu item with a small dialog that would show status in Windows or on a Mac that would tell us if it's enabled and working correctly?
Sorry, I can't hear you correctly.
Has your team ever talked about adding a little GUI or little application to report the status of HAXM? Right now, for example, I think in Windows you go to the command prompt and you do a query on a service to see if it's enabled.
Okay.
It would be nice if there was a little application you could run to show you the status so you would know.
Currently, we haven't such a plan to do it. You know, it depends on the resource or depends on the request. Currently, you are the one to give such a request for us.
Okay, I'll request it.
Thank you. So, any other questions here? No? So we are done.